Well, I have the honor of closing this event. So thank you very much, the organization and all of you for being here. It's really a pleasure. Yeah, so I'm going to talk about Python. We have talked a lot about deck.gl, which is basically JavaScript and that stuff. But why do we care about Python here, right? Most of data scientists are using Jupyter notebooks, and they are doing geospatial analytics, and they want to render maps. They want to plot some stuff. They want to render maps on Jupyter notebooks, and that's why we are caring about it. Okay, so does anyone know 5 Python tools to visualize geospatial data? Maybe you can raise a hand here, or maybe in the chat. I'm going to open the chat here on my phone so I can check it. Okay, so I guess no one. So you're going to learn something today, right? So this is good. Okay, so first of all, well, I have created a little repo with a bunch of Jupyter notebooks. I'm going to paste the repo here in the channel, so you can clone if you want and play with it, right? But I will do the same here in the workshop, right? So yeah, and basically what the setup is pretty basic. So you clone the repository, you create a virtual environment with Python, you activate this environment and install all the requirements. I have about all the requirements needed are in this file. And then those lines are for enabling PyDeck in the Jupyter Notebook, and finally you can run Jupyter Notebook. And don't worry about it because this is in the README in the repository, so you can play later with it. Okay, so well, we don't have a lot of time for this workshop, so I will do it a bit fast, right? So, but I think we all know about geospatial basics, but just in case, let's review it a bit. So we have two concepts here. We have geometry and geography. We have geometry, which is Cartesian representation, and geography, which takes into account the shape of the Earth. Depending on the application, it could be spherical, ellipsoid, but it's the geodetic parts. And regarding geospatial data, we have points, lines, and polygons with the multi option. So at the end, we have a combination of a lot of different geography types. Regarding geography formats, we have different systems. We have vector, raster, and grid system. I think you all know GeoJSON, well-known text, well-known binary. I don't know if you have played with tiny well-known binary, because it's really interesting also, shapefile, GeoPackage. Regarding raster, we have also a lot of them. I think more for raster because there are a lot of proprietary encodings or formats for it. And we have a different kind of geospatial, which is grid systems. Then we have H3, S2, GeoHash, QuadBean, and many, many more. And just to put a real GeoJSON for you to figure out, this is how it looks. So the GeoJSON contains type, feature, geometry. With it depends on the type of the geometry. It will contain a list of points or not. And it contains also the properties, right? So in the other hand, the well-known text and well-known binary are only storing the geometric information, right? And well, I think regarding just grid systems, you know most of them. So we know H3 grid, which is uses hexagonal grids. Also S2, which is really interesting because it converts the Earth into a cube, and does this Hilbert curve in order to get these cells. And both have a binary encoding, by the way. And S2 was invented by Google, so they use it a lot under the hood. For example, in BigQuery. And then we have others like GeoHash, that we all know. GeoHash, it's like a code for each point in the world. And QuadBean. Maybe QuadBean is not that known because we have developed here a color. Basically, it's a new encoding system for quad keys, for being tiles in this case, and it's highly inspired on H3. So it's taking all the advantages of the H3 encoding system, but with squares, right? So that's what a QuadBean is. We are using actually in our products. Okay, so geospatial with Python, right? we have GeoPandas stack. I don't know if you know this or you have played with it. Could you raise your hand just to, okay, a few? Yeah, Kyle. Okay, so yeah, for the rest, there's an ecosystem of projects for geospatial and, well, non-geospatial analytics in Python, right? So we have NumPy, which is the very basic that provides arrays and fast computations. Then on top of NumPy, we have on the one hand pandas, which creates these two concepts called data frame and series. So basically a data frame is a collection of series, and they have interesting properties and operations. And on the other hand, we have Shapely, which uses also NumPy, but also Geos. So Shapely provides geometry or geometry operations on top of it. Then we have Piper, which is a different project that is a wrapper of project. And GeoPandas uses all and creates a geodata frame and a geoseries. So it's an extension of Pandas. And here in this picture, you can see what is this? It's basically a data frame with an extra special column for geometry. Okay. Okay, so let's go to fun stuff. Geospatial data visualization in Python. Okay. Now it's notebook time, so I'm going to. I think everything is prepared. I have installed all the dependencies, so I can enter here in notebooks, and I have here a bunch of them. So we are going to review all of them and then go back to the slides. Okay, so I will try to run a bit here, but yeah, this is basic operation. I don't know if you can see it, or if maybe I can make it bigger. Better? Okay. Yeah, so basic GeoPandas operation. GeoPandas has a bunch of stuff, a great community, and it's really, really a nice tool. So in this case, I'm loading a local file with a GeoJSON, which is actually the same GeoJSON I put in the slides before. So yeah, then we can create another cell to check this out, right? So if we check this, we check that this is a geodata frame. If we check this column, it says that it's a geoseries. We can also see the first rows of this. Well, actually, there's only one row. And we can also plot it, right? So this is basically Shapely plotting stuff here in the notebook. And this is the polygon that I have created for the workshop, right? So, but then GeoPandas provides a set collection of data sets that you can use. So in this case, I'm loading this series data set. So you can see here that the representation for the geometry is in well-known text. And in this case, it's a list of points. And we can plot it, but nothing interesting here. And the same with this. We are using this natural earth data set that contains multi-polygons and polygons, and we can also select some. Maybe you can recognize this. Okay, so this is just the very basic stuff. So I'm going to show you different tools that were used or are still used for data visualization, right? So Matplotlib, maybe you know it. It's a tool to render plots in general purpose with Python. But in this case, GeoPandas has an integration with Matplotlib. So when you plot with GeoPandas, it uses Matplotlib under the hood, basically. So I'm going to run this, load both world and cities. We can check the content. Okay, this is the same, and we can plot it. So basically, this is a graph with axes, and it depends on the projection. It will look different or in these ways, right? And we can do the same with points. Okay, so we can plot geospatial data here, but we can do more complex operations like plotting with several styling, legends, and things like that. And this is getting interesting. By the way, all these are static plots, right? No deck.gl in this moment. Okay, and the next one is just a combination of two. It's not really straightforward in API, or I mean, it's really simple in code, but we can use it, but it's not the best tool to use with it. Okay, and I will show you another example using base maps here, because we can use base maps with Matplotlib using this context application, right? So I'm going to load this New York data. This is how it looks. So, and then I'm going to change the coordinate system, okay, because it's in this coordinate system, which is special for New York, I guess. And we are going to convert it to web Mercator in order to mix it with base map, right? So we can check that this has changed, and this is as easy as this. And then we can add like, yeah, let's see, because it loads the base map, and you have a plot, but with a base map. Actually, we can plot using CARTO-DB base maps here, raster, which is what I'm doing here. And yeah, this is cool. We can have this. This is also a static image, but with matplotlib. Okay. And the next one, I'm going to pass to another one, which is maybe not that famous, which is geoplot. I think it's a project which is not in highly development, but it's interesting to check. Okay, so I import this geoplot project. I'm going to close this other tab, by the way. Okay, so let's run this. Yeah, I'm going to go fast here. This is how it looks with matplotlib with GeoPandas, and this is how it looks with this. So it's taking care of removing the axis and trying to make it a bit prettier, right? And then the same with polygons. We can combine these. I cannot do projections, which is a strong point of this library, because I install it with pip, and I think I need to install it with Con in order to make it work. But I can do things like this with legends, some styling, and things like that. So just for you to know that this exists, right? Okay, so I don't know. It's because of this stuff, right? So let's move to the next one, which is volume. Maybe it's a bit more known. And this is basically a wrapper on top of Leaflet, right? So Leaflet provides you raster maps with DOM objects on top, and it's a really popular tool, and I really like it. Actually, GitHub uses to render JSON in GitHub directly. And this is a wrapper on Leaflet to render maps, right? So let's check it. So yeah, in this case, we're loading data. We are converting this, and this is how it looks. So the API is really straightforward volume map, and then it renders a map, and it also allows to use CARTO-DB positron base maps, which are actually raster base maps. Okay, yeah, in order to plot something, we can, this is the way, or I don't know if it's the way, because I am not a user of volume, but this is one way of adding data on top of it, right? So I'm adding those polygons here, and then I can compute the centroid, get back to the original coordinate system, and put everything together, right? So basically we have a raster base map, and on top of that, we have polygons and some markers. We can interact with it. We have tooltips too. But the difference is now this is moving, this is interactive, and it's more interesting. Okay, so yeah. Oh, I think it's better to move it. Okay. Okay, so the next one is like the brother of volume, which it's IPO leaflet, which is really explicit, right? It's a wrapper over leaflet, like volume, but with a different API. So basically for the workshop, I tried to replicate the same example, which is actually in GeoPandas documentation, but with IPO leaflet. So we are loading this in data. Yeah, we are creating the map, which in this case is IPO leaflet map, base map. Also, we can load the same stuff, and it looks really similar. But it has a different API, right? So in order to load this geodata frame, they have this geodata object. Then I can add a layer with it with a specific styling, and you can see that I can reach the same styling. So under the hood is really similar, and we can do the same with the centroids to plot some markers here, right? So here, basically, in this loop, I'm creating markers and adding into the layer. I don't know if it's the best way to use it, but it's a way to do it, like with volume, right? Okay, so let's move to more interesting stuff, which involves deck.gl. So basically, Kepler Gear is an application, it's a React application, really cool, that you can embed directly in your Jupyter notebook. So you can put the entire application here and then load a data frame and then plot it here, right? So let's do a quick sample of this. I create a map, and this is the entire React application here. You can have here all the menu and all that stuff. So it's like in a browser. Um, and then I'm going to load this file with, it's a bit big, and then load it here. So notice when I, yeah, it takes a bit of time because it's loading like local data, right? Uh, so notice that when I add this layer or this data into the map, the original map is updated. Okay, so this is how it looks. And by default, it comes with styling stuff. I think I can come here and style this with a variable. Okay, so yeah, it's interesting. By default, it contains pop-ups and all the stuff that the main application has, right? And other cool stuff is that you can store the map in an HTML file. So let's do that. Okay, and I can go to the notebook and open this file, and it loads basically the same stuff, but in a different. Okay, here it is. Okay, so this is Kepler, but maybe for your application, you don't want to embed an entire application in your Jupyter notebook. You want something more like a pure Python wrapper on top of deck.gl. And this is the next one, which is PyDeck. We have here Andrew. I don't know if it's over here, but he's the creator, and I want to thank him for creating this project and also all the entire deck.gl community, because this is really, really amazing. Okay, so how this works? This uses deck.gl, of course, and basically how it works is like Python generates a JSON file that passes to the JavaScript. So they're using the JSON converter specification of deck.gl, and yeah, and basically that's all. Let's run an example so I can talk a bit about. Yeah, so PyDeck mainly has three components: the layer, the view state, and the deck, which is actually the map, right? So you can create all the layers that are available in deck.gl can be used here. The core layers are directly available. So you put here the type of the layer and then the parameters, and this gets mapped to JavaScript. The same with the viewport, and the same with PyDeck, with the deck object. So you can put here a lot of layers, and yeah, change the base map, also store it in an HTML file. Yeah, it's really, really interesting. So you have basically all the application with interactivity. You can put pop-ups, you can style. So it's really, really cool. In this other example, well, this is loading two layers. So here I have the polygon layer and a GeoJSON layer, and I'm getting the information from a URL or just static data in the notebook and getting rendered here, right? So I can save this in an HTML file and put it whatever and share. And yeah. And finally, in this example, it's using a GeoJSON layer with a natural earth data and a text layer. So basically, whatever you want, you can use it here, right? So yeah, it's really cool. Let's go back to the slides. Okay, so we can do a quick recap. We have matplotlib, static maps, also geoplot that uses under the hood matplotlib, volume and ipleaflet, Kepler with uses deck.gl, and PyDeck. Actually, PyDeck has a really cool feature, which is updating the layer. So you can, in a cell, create kind of animations and update the main layer. And I use that with really cool stuff. So let me show this. This is basically, I don't know if you know Lego Spike, but it's really interesting tool. So I started playing with my kids, but then I started developing this kind of stuff. So I'm reading the sensors and the encoders from the Lego devices, and with through a serial port, I'm sending information to the Jupyter notebook and then updating the map. So I can control basically the map with it, and it's something really cool that we can do also with PyDeck. Yeah, this is the next product. Okay, and we have others, right? We have CARTO frame.
tenemos en estos.
Can you hear me? Yes. Awesome. Yeah. Okay. So yeah, let's continue. Let's go with the last part of the talk. Yeah. All right. So yeah, let's go to the big data visualization problem, right? So we were like talking about that in CARTO. We this is our main purpose is like bring data from different data warehouses, which is usually a huge amount of data, and trying to analyze, to visualize, and all that stuff, right? So this is the final notebook time, and I'm going to show you a project here. Yes, that it's actually a little project. It's still in beta, but it brings the idea of adding multiple models to PyDeck, right, for different non-core purposes. So yeah, in this case, we have developed two Python libraries, one for CARTO authentication and the other, which is PyDeck CARTO. And yeah, in this case, I'm going to log out of my account just to show you how the authorization system works, okay? So I log out, and then I call this CARTO auth from auth, okay? And then this, well, I'm going to disable cache so you can see it. So basically it pop-ups a login authentication system, so I can continue logging with my Google account and I end up in a success page. So then from this point, from now on, I have a token here that I can use to render my maps. And the second part of the text is the register CARTO layer. And this basically is because PyDeck doesn't know about the CARTO layer, so I need to explicitly register in that. And then, yeah, the next is the same. We can render, like in the CARTO layer in JavaScript, queries, tables, and tile sets. And this is getting all the information directly from the data warehouse. In this case, the CARTO data warehouse, which is a data warehouse that we provide to all CARTO accounts. And yeah, the rest of the API is basically the same as with PyDeck. But we have also included some styling because at CARTO we take well, in this case, I'm rendering an H3 layer. I think this comes from a already generated tile set. Okay, so you can see here how data is getting loaded, and the same with Quadbeam. And in this case, it's generating tiles on the fly from I think it's 15 gigabyte table. Okay, so it's basically the same. When I zoom in, I can get all the details and all the information really, really fast. And yeah, regarding color styling, we have developed some functions in the JavaScript side, in the CARTO module, and we have created a bridge to be able to use it from Python. And the good thing about it is that it can be used with any kind of layer. At CARTO, we have developed some palettes some years ago with colors, and we can use it directly here, pass the domain, and it's using D3 under the hood to do all the interpolation stuff. So we can have like nice maps really, really quick. Yeah, so we have this another example which uses categories, so strings as an input for the styling, and finally continuous style. And we have included something about error management, because what happens if you put the wrong column, the wrong name of the connector or whatever, we don't get feedback, right? So we have developed this function, so we get the on the error callback, and we plot it here. So in this case, instead of a map, you get a message actually. I don't know if this is the final API or if we are going to include it directly in all the layers, but this is something really useful when you are playing with it, because if the error happens in JavaScript, you cannot get it here in Python. And this is a way to connect it and to see it here. Okay, and yeah, this by the CARTO is also available for testing. So yeah, and also contributing. So yeah, I think that's all from my side. So yeah, thank you very much for your time, for your patience, and for being here, and also for all the contributions that you are doing to the open source project and open source community. So thank you.